So the idea of test distribution in Gradle Enterprise is to extend the test parallelism by fanning out test execution to remote executors, and then letting the build tool coordinate partitioning of the test set and collection of results. So let me explain that picture below. On the left, we have a Gradle project that is checked out to a developer or CI workspace. On the right, we have Gradle Enterprise, which is an on-premise server application, and we have a couple of agents connected to it. So now we want to run tests. So the first step for that is we have to discover the test set, which is the set of test classes we want to execute. Once we've done that, we can request agents from Gradle Enterprise, and Gradle Enterprise will estimate the number of agents we are likely to get and send the number back to the build, which will use it to partition the test set into chunks and then start test execution. These agents then get assigned to the build by Gradle Enterprise and request test inputs from the build. So here we have the inputs again that have come up before. So the inputs are, for example, test classes, the jar files on the test class path, or any additional inputs that the tests read. They have to be transferred to the agents to replicate the workspace that the build runs in to a certain extent, to that extent that the tests need. Once that is done, the inputs are sent from the build to the agents, and also the partitions are sent to the agents that they are supposed to execute. So like which test classes should run on which agent. The agents then cache the inputs. So next time they run maybe the same project or a different project, they wouldn't have to request all the resources again. For example, think about the test runtime class path. You might have JUnit on there, for example, and usually you don't upgrade JUnit with every build, so you can reuse the same jar file the next time. And also you only have to transfer those tests that you need that have changed. Once that is cached, execution of the test is started on each agent that is assigned. And as tests are executed, results are continuously reported back to the build. And in the very end, the outputs of the tests are also transferred back. So this might be additional output files that the test classes write, or some additional reporting, or for example, if you use a code coverage tool like Jacoco, it might be the coverage data that is basically recorded while the tests are executed. So those outputs are sent back automatically to the build and then merged and stored by the build, in this case our plugin, in the workspace in their usual location as if tests had been executed locally. So that's the overall flow. And we will support both Gradle and Maven for this. Gradle is coming first. So in April next month, we will release it for Gradle first, and then Maven support will come in the next release. So that's already planned. These are the current estimates when you can kind of use it. So as I said, Gradle in April, the Maven support will probably come in June. Maybe if we're faster than that, of course, earlier. So we won't wait for June if you have it ready. So we will support Maven and Gradle as we already do for build scans and the build cache. Yeah, now it's time to take a closer look from a developer's point of view. How does it actually work? How do I have to change my build? And for that, I would like to pass it on to Benedict.
All right, so we prepared a little demo for you. And at the very first, I would like to start a Gradle build on this project. Just a second. All right, what? Sorry about that, probably a typo. Run tasks. Okay, now we're going. And as this build is executing, I'd like to show you around in the project a little bit. As you can see, I've opened the build script already, and we are using JUnit Jupyter. I saw there was a question which test frameworks will be supported by distributed testing, and we have a slide for that later. For now, I'm using JUnit 5 in this project. This project is actually a generated project that we use at Gradle to test the performance of the Gradle build tool itself. So it has some artificial classes that have a set of properties. They all look the same. It has 100 classes and they all have some properties. What is more important for the testing and distributed testing webinar is how the tests look like. And we have a matching test for each production class. So we have 100 production classes that makes for 100 test classes. Each test has 10 test methods, summing up to 1,000 tests that are executed. And each test sleeps for 100 milliseconds. So they are fairly equally distributed regarding their runtime, which might not be the case for every project, but it makes the demo a little bit more reproducible. So as you can see, Gradle is having a hard time working through all the tests because I have to execute 1,000 tests now that all have this sleep. And we'll give it some time to finish with that. And while it's burning through the tests, we can see that the build time of this build was actually 1 minute and 47 seconds. And I guess that's something that's kind of what people experience in their day-to-day workflow. It's like 2-minute build. Yeah, let's just build this and wait until it's finished. But it was already quite some time during this this presentation, right? So what can we do about it? As Mark explained, the first thing, the most easiest thing is to increase the single machine parallelism. And we have this flag on the test task, or this configuration on the test task called max parallel forks. And the default setting for that is 1, meaning that I just use one VM fork and all tests are executed sequentially. And I've now set it to 2, and we can see the effect by rerunning this build. And what we will see is that that this already dramatically speeds up the build. So I have a pretty beefy machine. I could theoretically run more forks in parallel, but for the sake of the demo, let's assume that 2 is all my machine can handle. And it really depends on your tests and what they are doing. If they have to spin up, I don't know, some Docker containers because you're using test containers or something like that, that might be all your machine can handle at once. And as you can see, we already executed 600 tests and we are at about 30 seconds. So it seems to be faster already. And we should land by somewhere at 55 seconds or something like that. But still a long time waiting for test execution. And here we go. We have finished executing tests, this time in 55 seconds. So that's already pretty good, better than before. But if this is all my machine can do, what do I do if I want to speed it up even more? Well, this is where test distribution comes into play. And to activate that on the build, I just have to apply the distributed testing plugin. And what this will do, it will create a new extension on the test task. And to make that available in IntelliJ, I need to do this little IntelliJ dance that recreates the model. And after I've done that, I can configure my test distribution. So I have this new configuration object here on the test task. And what I need to do is I need to enable it explicitly because we decided that you have to explicitly opt into distributed testing because your tests, they have to be kind of self-contained. So you can't have, for example, a task that's running before the test task that spins up a database for you, simply because that wouldn't be executed on the agents. So let's see what happens now if I run again with test distribution enabled. And this actually now connects to our distributed testing infrastructure on AWS. We have 12 agents deployed to our Kubernetes cluster. And as you can see, it speeds up the build dramatically. So we started with 1 minute 47, I think, and now we are down to 14 seconds. Imagine what this would mean for your productivity on a day-to-day basis. Also, we can see there was a link created. This is actually a build scan link. If you did not have a chance to let me quickly go to my browser and open that. So build scans are a feature actually of Gradle Enterprise. And if you did not have a chance yet to look into that, we have some webinars and some content available that give a good intro into what Gradle Enterprise can do. For now, all I want to say about it is that it has like a record of what happened during the build. And we will go back and forth between IntelliJ and the build scan to observe various things. So the build scan also collects some data about distributed test execution. And as you can see here, I have the name of the test task that I executed. It's called :test because it's the default test task. And this build got assigned 14 executors. And this is the sum of the 2 local executors that I configured before by setting the max parallel fork setting. And it got assigned 12 remote executors. So if you use distributed testing, it will never be slower than executing on your machine, because your machine will start executing using the local executors already. And after some time, as Mark explained, the agents that are assigned to the build become available, and we can actually see how long that took from beginning of test execution until they reported that they are ready to start executing test petitions. So it was about 300 to 500 milliseconds for each of the agents. We also record some of the file stats, for example, how many files we needed to transfer and how much bytes that were in sum. In this case, because I did this before the webinar already, I did not have to transfer any files because they were cached. All right, so let's talk about test reporting. What happens there if we use test distribution? And you might know that there is also some configuration on the test task that you can use to increase the logging. And I've just configured it here to output in the console view the passed, failed, and skipped events. So whenever a test fails, passed, or skips, it will be logged into the log, because usually the test task doesn't log anything at all. It just executes and is done. This little display granularity thing is to output the maximum detail. And if we run the tests again, then we will see that the executors start reporting. You can see, I don't know if it's visible in the recording or in the webinar, but the local executor reported some events here, and here we can see, for example, that we have the partition 7 that was executed on some agent. This is a name that was generated by our Kubernetes cluster, and we see that this test actually passed. We also get a test report. So if I open the test report, I have to move it to the other screen. Give me a second. So it's just the usual test report that you know from Gradle. It looks completely the same. Everything, no matter where it was executed, is collected here in the report. And there's one little thing. If I go into one test, I can navigate to the output and I see where it actually was executed. We generate an artificial output event for you so that you can see where this was executed. So this test actually ran on my local machine, so it was executed on the local executor running on localhost.